Now last year you will have spent some time learning about mixtures and how to separate them. So this is again presumed knowledge, but knowledge you would have gained just last year, so hopefully it's still in memory bank somewhere. So what you need to know? Well, you need to know about pure substances and mixtures and be able to identify each. You need to know about solvents and solutes. You need to know about how a whole range of things can be done to separate materials. Again, that ties in nicely to that idea of recycling, and industrial use of chemistry. So there's physical techniques and chemical techniques which sort of allow us to pull things apart. And you hopefully explored and compared separation methods used in the home, because we actually do use them at home. So we haven't talked much about atoms yet, and we will get to there. Atoms are pure substances, just made of one type of thing. So my gold ring, which you can't see, it's just gold. They're all gold atoms. Well, it's not that pure, but basically it's just all gold atoms. This cake we describe as a mixture. We're taking a whole lot of stuff. Some of them are compounds, some are pure substances, and we've just plonked them all together and made a yummy cake. But it's a mixture of stuff. So we don't have a set formula to what's in there. There's a recipe. We put so many eggs and so much milk in them. But each of those things has a whole lot of stuff in it. So we don't have real control or knowledge of exactly what atoms are present. And that means it can't be called a compound. We'll talk about compounds later. So separation techniques basically can pull mixtures apart. So some parts of a mixture will, of course, have made some chemical changes. We can't do much about them. But generally, most mixtures haven't joined chemically, so you can pull them apart again based on their physical characteristics. Things like the size, what temperature they boil at, what temperature, if they're magnetic or not, how dense they are, so whether they float or sink. So these are all things that you will have used, hopefully, last year. You would have sieved. I think humans have probably been sieving for a very long time, because one of the early things to do was to get that grain you've harvested and get the chaff out, because you want the edible bit, not the inedible bit. And so being able to filter it in some way, some sieving attempt, was really important. So sieves just rely on size of the particle. Big stuff gets left behind, small stuff falls through. And it's used in all sorts of applications. Still, as simple as it is, it's a very effective way of separating things. You would have used filter paper, I'm sure. So here we're looking at trying to get really fine stuff out of our solution. So in this case, we're looking here at its residue that's stuck in the water, and with some nice clear water coming through. This is the filtrate, so it's been filtered, and we've removed this residue, and it sticks to that filter paper. So it's like a sieve, but it's a really, really fine sieve. So it's still sieving, essentially. You would have hopefully had a little ceramic dish full of salty water and boil the water off. Easy. Water boils at fairly low temperature, just around the 100 degrees Celsius mark. Salt, which is a common thing here to boil off, boils at 1465 degrees Celsius. So clearly the salt gets left behind. That's okay if you want the salt. If you want the water, not so useful. But we can do something different. And you set a still. And in this case, here's some water and something else in it being boiled. And the steam is then captured. And as the steam comes down here, you've got cold water coming in the top, and then as you throw in the bottom, and forcing its way up. And this takes the now warmed water out, and you constantly replace that with cold water, so that cools the steam. And if it's working well, you should have nice clear water, or sometimes you do this for eucalyptus oil, perfumes, get the perfume out of the flowers. That's what you're trying to collect, and leave everything else behind. Sometimes you've got double distill, even triple distill to get really pure substance you want, depending on what you're trying to do. That way, at least you get to capture what's boiled off and not lose it, like you did in the previous one with the evaporation. Paper chromatography also uses the idea of size. So in this case here, This is where our ink was put on the piece of paper. Hopefully you did this last year. And this coloured pen is made up of 3 inks. Red ink, purple ink, blue ink. And the solvent, so obviously you can put it in water, can be the solvent, I think it'll dissolve it, or you may have put it in methylated spirits, quite a common solvent for this purpose. So the red dye reaches 2 centimeters from where it started, but the blue dye reaches 8 centimeters from where it started, and we can see here that the solvents, so this piece of paper is now completely wet, right at 10 centimeters. That means the blue ink is smaller than the purple ink, which is smaller than the red ink. The bigger the dye, the less distance it can travel, so that the particles that make up the dye. Used a lot in pharmaceutical production, paints, inks, that sort of stuff, and also forensic science. When you want to work out what substance you're dealing with, you can use, well, you probably use gas chromatography, same idea, but you try to find out what's in there, and you can test that by distance they travel. Flotation. So some things float. We used to take you guys down the poo farm at Mount Martha, and they use flotation there to help clear the water. The classic one we normally do in class with a separation funnel is oil and water. Oil sits on top of water. It's less dense. And so you need to actually pour the water off and trap the oil inside your container. In recycling system, good way to get the plastics, because they're going to float on top and you skim them off. So flotation is very useful, that idea of density. Very interesting way of doing things. The centrifuge, we've got one at school, so hopefully you got to use it last year. Centrifuge is commonly used in blood sampling, but all sorts of chemical stuff, so that it's using gravity and again density. The heaviest particles will collect at the bottom. This thing spins at high speed, and so it throws as a centrifugal force, throws the heaviest stuff to the bottom of the tube, and the lighter stuff stays on top. And when they come out, you see quite clear gradations of how thick, how dense different products in that solution are. So gravity is quite a good one too, in that sense, depending on what you're trying to work with, of course. And these come in different sizes for different jobs. Magnetism, nice, easy one. Those things that are magnetic, quickly separated from other stuff just by putting a magnet over. Good way of recycling metals, of course, or getting them out of wastes, and clearly often used because metals are one of those resources that we only have so much of. So very handy. And that's separation techniques. Now, I didn't talk about solutes and solutions, but I think I've got that in a separate video for you because it's got a lot in that one. But for now, we'll finish here.